students, I'm NEETA Upadhyay and I'm going to teach you work and energy with its part 4. Students, as we have already discussed about type forms of different energy different kinetic and different forms we have already discussed, and we are going to study in detail about kinetic energy. The kinetic energy of an object is the energy possessed by the object due to its motion. Student, when an object is moving, it is possessing kinetic energy. A moving object is capable of doing work because of its motion. Hence, we say that the object has kinetic energy. Kinetic energy means energy due to motion. The energy is stored in the object when work is done to change its velocity from a lower level to a higher value. Okay? So energy is stored in the object. Whenever an object is moving, the energy is stored in the object and work is done to change its velocity from a lower value to a higher value, or from rest to certain velocity. So all what is kinetic energy? It is an energy, or kinetic energy of an object is the energy possessed by the object due to its motion. When the object is moving, it is possessing kinetic energy. All moving objects possesses kinetic energy. A falling coconut, a speeding car, a flying aircraft, flowing water, blowing wind, running athlete possesses kinetic energy, and hence they are able to perform work. The kinetic energy of an object depends upon its speed, that is velocity. An object moving faster has more kinetic energy than an object moving slower. So if an object is moving very fast, okay, then another object which is moving slow. So the object moving with object moving with more velocity will have more kinetic energy than the object possessing less speed. So let us see the examples of kinetic energy in our everyday life. An arrow released from a bow flying through the air. Now this is the arrow already released and it is flying. That means it is moving. So it is possessing kinetic energy. An object rolling down a hill. Now here a person is cycling. Now when this motion is occurring, okay, this movement is taking place, it is possessing kinetic energy. Muscles are moving. They are possessing kinetic energy, movement of the muscles. A car moving, here also the motion is due to kinetic energy. That's why it is able to perform work. Energy is what? Energy is the ability to do work. Shooting a rubber band is shooted. Water falling over the fall. Now here the water is falling. Now this is also motion. Movement is there. So kinetic energy. A yo-yo in motion. Yo-yo, you know that. You sometimes you play, no? The ball is bouncing. Okay. Now this is also kinetic energy. Releasing the arrow from the bow. The arrow is released. The bow is moving like this. So it is possessing kinetic energy. So these are the everyday examples in which we can find out that when is kinetic energy being used to perform work. So let us derive an expression for kinetic energy. Okay, a formula to find out kinetic energy of an object. For this, we will consider an object of mass m. Here, you consider an object of mass m which is moving with the initial velocity u on a perfectly frictionless surface. Okay, let a constant external force F, okay, now of F is acting on it and producing an acceleration A in it. If V is the final velocity, now the object has moved and it has reached the final velocity V, having undergone a displacement from this position to this position, displacement S. Okay, so now using this information we are going to derive an formula for or expression for kinetic energy. Students, we know that now due to this motion the work is done. Okay, here work is done, no, because force is applied and the displacement is taking place in the direction of force, and now the work is done. So first we will write down the work done by the force in displacing the body through S. Okay, the expression, what is the expression? W is equal to F into S, which we know that work done is the product of force and displacement, and you write it, this is as equation 1. Next, we know the third equation of motion. Now before this, I just want to explain this. First you will take the formula, since the formula work is equal to F into S. Why? Because when the object is moving and force is applied and displacement is taking place, that means work is done. Okay. Now here you just concentrate, here two quantities, force and displacement. We have to find out a quantity which can be written here in place of F and S. Okay. So for F we know the equation, second equation of, for S we will find out, in place of S we have to write something. That is, using third equation of motion, we will use V square minus U square is equal to AS, which can be written as, okay, we want S to be substituted. So we will take the S on the other, we will put the 2A on the other side. Okay, so here S is equal to, this 2A will be transposed on the other side, here it will come, so it is multiplied, so here it will be divided, this way it will come. So we will get the equation S is equal to V square minus U square upon 2A. Now we have a quantity which can be substituted instead of S. Okay, similarly we want a quantity which must be substituted by F. Okay, so we know that Newton's second law of motion, which says that F is equal to F is equal to m into A. So now we got S, something to substitute in place of S, and we have something to substitute in place of F. Now we will substitute equation 2 and 3 in equation 1. So instead of S we will write this equation, and instead of F we will write this MA. So substituting equation 2 and 3 in equation 1. So students, W is equal to MA, and you will get MA. How you got? Instead of F you have written MA, and instead of S what we have to write down? V square minus U square upon 2A. Okay, and now students, we can cut this. Okay, see, A and A can be cut. So when you cut this A and A, you will get final equation M is equal to V square minus U square upon 2. Okay, can you see that it can be cut now? Here you cut it. Okay, and then you will get M is equal to this. Now this equation can also be, if you will open the bracket, what will happen? MV square upon 2, and this will also become MU square upon 2. Okay, so next we can also write that W is equal to half mv square upon 2 and minus half mu square upon 2. Okay, we have opened the bracket. Now this will become equation 4. Now next is, students, if we imagine that the object is initially at rest. Okay, here if you imagine that the object is at rest, or you can say that the initial velocity is 0. So what will happen to this part of this equation? Half mu square, this will become 0. If this will become 0, this whole quantity will be 0. So what will be left? W is equal to half mv square. So if the object is initially at rest, u, that is u is equal to 0, then equation 4 becomes W is equal to half m upon 2 p square, that is fifth equation. Now here, now we got the formula, student. Work is equal to half mv square. Now work is done. Here work is done, and what is work is done because of the energy. Okay, and the energy is in the form of kinetic. Okay, and which type of energy it is, which is due to which the work is done, that is kinetic energy. So work is stored up in a moving object. Since the object is moving, the work is stored up in a moving object in the form of kinetic energy, which is denoted by ek. Okay, so instead of w, we will substitute ek, because the work is being done in the form of kinetic energy. So ek we will write down half mv square. Student, this is what is our expression for kinetic energy. Okay, and this expression half mv square is also useful in finding out the value of kinetic energy in numericals also. So now what we got, kinetic energy is the energy of motion by definition, and it is given by the formula or expression is k is equal to half mv square. The equation shows that, what the equation, from the equation what you can understand, that more is the mass of the body or faster it's moving. How much mass is more fast it will move, more kinetic energy it got. So more mass, more kinetic energy. If the object will move fast, then more kinetic energy. Okay, if it will move slow, that velocity is less, then the kinetic energy will also be decreased. So k is proportional. Okay, k is proportional to v square. So when we double, so doubling the speed, we will get quadruples kinetic energy, and tripling the speed makes it 9 times greater. If we will triple it, okay, triple it, then it will become 9 times greater. Okay, so if you will double, so this is what, because k is directly proportional to v square. If the velocity is uh, 2 the whole square, then the kinetic energy will be 4 times. Okay, if it will be 3 square, then it will be 9 times. Okay, 3 square is what, 9. So kinetic energy will be 9 times. Okay, greater. So students, in this way we have done what is kinetic energy, and we have found out the formula. So let us solve some sample problem. Very simple it is. What is the kinetic energy of a car with a mass 2000 kg moving at 30 meter per second? So here mass is given as m is 2000 kg, moving at 30, that means velocity is 30 meter per second. So we will first write down the formula, k is equal to half mv square. Half, instead of m, that is mass, we will write down 2000 kg, and then v square means 30, we will write down the whole square. So when you will calculate, you will get as this 2 ones and this 2 will cut, you will get 1000 into 30, then this will become square, that is it will become 900. Okay, 900 into this, 900 into 1000 you will get, and that means it will become 9, this much you will get. This is the answer, and you will write the unit also, joules. Okay, same, we know that, no, what is the unit of work, that is the same unit is for energy also, joules, because energy is the ability to do work. So in this way students, we have you must have understood about kinetic energy, how to derive some examples, how to derive it, and for how to use that expression in the numericals. With this students, thank you and take care.